Hello. Okay, so today we're going to be solving one-step equations. So to solve a one-step equation, it's as straightforward as it sounds. It's just one step. Oh, going the wrong way. Alright, so what you need to do is you need to perform one step in order to solve the equation. So these are called inverse operations in order to solve a one-step equation. An inverse operation means the opposite of what the operation is. So what operation undoes or doesn't basically reverses what you're doing? So for example, addition undoes subtraction. Subtraction undoes addition. What do you think multiplication is the inverse of multiplication? Well, what's the opposite of multiplication? How could you reverse multiplication? You do that by division. Okay, so let's start with easy equations. Let's start with solving equations using addition or subtraction. So if a number has been added to a variable, how do I get rid of adding something? I would subtract. So if a number has been added to the variable, subtract that number from both sides of the equation. What if a number has been subtracted from the variable? So how do I get rid of subtracting a variable? I would simply then add. And of course, whatever we do to one side of the equation, we must do to the other to keep it equal. We want to keep that equilibrium on both sides. It's almost like a scale. You have to maintain the scale, okay? So let's look at the first example. First, we do what is happening to the variable, and then we answer the question, what is the inverse operation of that of whatever's happening to the variable? So if I look at it, I have m plus 7 equals 11. Okay, so I'm going to ask myself, what is happening to my variable m? If I look at it, it's being added by 7. Okay, how do I undo adding 7 to m? Well, to undo adding 7 to m, I'm going to subtract 7 from both sides of my equal sign of my equation. Now I have 7 minus 7, which cross out and give me 0. Now I have 11 minus 7, and 11 minus 7 is 4, so m equals 4. Now, always we want to be safe, so what we do is we're always going to resubstitute back in to check the equation. So to check the equation of m plus 7 equals 11, I would take the m, substitute it with my answer, which is 4, which then is going to give me 4 plus 7, and 4 plus 7 equals 11, and yes, that is true, 11 equals 11. So, doing the inverse operation for addition is as simple as subtracting on both sides. Alright, now let's look at another one that has subtraction. I have negative 6 equals to m minus 4. I look at what is happening to m. Again, m is being subtracted by 4. How do I get rid of subtracting 4? I simply add 4 to both sides. So what's negative 4 plus 4? They cross out and go bye-bye. Negative 6 plus 4 is negative 2. M equals negative 2. Now to check, I just plug in the negative 2. So therefore, I'm going to have negative 6 is equal to negative 2 minus 4. And what is negative 2 minus 4? It is negative 6. Is negative 6 equal to negative 6? Yes, it is. Therefore, that answer is correct. Now let's do a practice. Here are two practice questions. The first one says j minus 3 equals negative 12. Okay, first thing we ask is, what is happening to the variable? It is being subtracted by 3. And we know the inverse of subtracting 3 is to add 3 to both sides. And of course, negative 3 plus 3 is 0. They go bye-bye. Negative 12 plus 3 is negative 9. J equals to negative 9. My next question is negative 4 plus r equals 26. Alright, what is happening to the r? Now you have to be very careful with this one. It's being added by negative 4. How do I get rid of negative 4? Well, I would subtract negative 4. And to subtract negative 4 is the same as saying adding 4. So I would add 4 to both sides. Negative 4 plus 4 goes bye-bye. And of course, 26 plus 4 is 30, so r equals 30. So that is how you add and subtract, or use a one-step operation with addition and subtraction. Now let's look at solving equations using multiplication and division. So, what is the inverse when I'm multiplying? Well, what's the opposite of multiplying? It's as simple as dividing. Now, what if a variable is being divided by a number? Well, what's the opposite of division? It's going to be multiplication. So the inverse of multiplication is division, and the inverse of division is multiplication. Alright, here's my next example. Example 3 says solve 3y equals to 261. So the first thing we ask ourselves again is, what is happening to the variable? The variable is being divided, the variable is being multiplied by y. So how do I get rid of multiplying 3 to y? I'm going to divide 3 to both sides. And 3 divided by 3, it crosses out, but we don't put 0. 3 divided by 3 is not 0. Please pay very close attention to that, because 0 times anything is 0. 3 divided by 3 is actually 1, but we know we don't have to write down that 1. We just simply have to say y. Okay, now 261 divided by 3, if you can't do mental math or by hand, go ahead and use a calculator. 261 divided by 3 is 87. So y equals 87. And of course, we have to do the check. And how do we check? We substitute the variable for our solution, our answer. My answer was 87. 3 times 87 is, well, what is it? 261. Is 261 equal to 261? Yes, it is. So good job. Alright. Now, what if I want to multiply by negative 1? What if I had like a negative w equals 42? Negative w equals 42. Well, we know from every variable that doesn't have a number, there is a invisible 1. So technically speaking, that is negative 1 times w equals 42. So when negative 1 is being multiplied by w, of course, we're going to add that 1. To undo the multiplication of negative 1, we're going to divide negative 1 by both sides. So negative 1 divided by negative 1 just gives me simply a w, because negative divided by negative is a positive, and 42 divided by negative 1 is negative 42. Now, there are other ways to do this. I could also multiply both sides by negative 1. It's the same process. Just understand that when I have just a negative, I can either divide both sides by that negative 1, or I can multiply both sides by negative 1. It becomes your choice in this case, okay? Now, of course, to check, what we do is we're going to substitute our variable with the answer that we were given. Our answer was negative 42. I'm going to do negative times negative 42, which equals to positive 42. Is that correct? Yes, it is. Good job. Now we're going to try a practice. Here are 2 practice questions for you. Negative 6x equals negative 36. B divided by negative 4 equals to 12. Alright, let's do the first one. I want you guys to pause the video for a moment, do it on your own, and then replay the video and see if you got the right answer, okay? And please, you have to be honest with yourselves as you do this. Alright, so negative 6x equals to negative 36. My variable is x. What is happening to my x? I look at it and I say, okay, it's being multiplied by negative 6. How do I get rid of multiplying negative 6? The opposite of multiplication is? Yes, that is correct. Division. So I'm going to divide negative 6 on both sides. Negative 6 divided by negative 6 gives me a positive 1. They cross out and go bye-bye into a 1. And negative 36 divided by negative 6, and negative divided by a negative is a positive, which gives me positive 6. Alright, next one, now I look at b divided by negative 4 equals to 12. Alright, what is happening to b? B is being divided by negative 4. What is the opposite of dividing negative 4? Yep, the opposite of division is multiplication. We're going to multiply negative 4 to both sides. So negative 4b divided by negative 4 crosses out, and then it's going to give me a positive b. 12 times negative 4 gives me negative 48. So my answer is B, equals to negative 48. Alright. Now the next example we're going to do is using reciprocals, okay? And if you guys remember what reciprocals are, reciprocals is when we take a fraction and we flip it. So if I had half, it becomes 2 over 1, or just 2. If I had 2/3, 2 over 3, it becomes 3 over 2, okay? So I look at it and I say, alright, my question is 3/4 W equals to 3. I have to figure out I have a fraction being multiplied. So why do we use reciprocal? It's a shortcut. I'm going to explain to you real briefly. So it's 3/4 is being multiplied by W. Okay, how do I get rid of multiplication? It's by division. Now, if you remember, when we divide our fractions, let's see if it lets me write on here. Let's see if it allows me to write. Nope, it doesn't want me to write. Okay, so it's not going to allow me to do it. So I was thinking, when I have 3/4, if I'm dividing it, remember that we do keep, change, reciprocal for division of fractions. So it's going to keep it. We're going to change division to multiplication, and we're going to take its reciprocal. So we're going to skip that whole process and go straight into multiplying the reciprocal. So what is the reciprocal of 3/4? The reciprocal of 3/4 is 4 over 3. So I'm going to multiply both sides by 4 over 3. So now I have 3/4 W equals 3. So I'm going to multiply both sides by 4 over 3. 3/4 times 4 over 3 is 1, because 12 over 12 is 1. And the other one gives me 3 times 4 divided by 3. 3 times 4 is 12. 12 divided by 3 is 4. So my W is equal to 4. How do I check? Well, I plug it back in, the answer. I'm going to do 3/4 times 4. Okay? 3/4 times 4 is going to be that 3 times 4, which is 12 divided by 4, which equals to 3. And does 3 equal to 3? Yes, it does. Good job. Awesome. Okay. Now, you have 7 questions for homework. The practice for each question, you're going to write the inverse operation that will be used and solve for each. Solve for X, then check. There will be a document, a Word document that you have in the assignment page. Please download that Word document. It already has the questions typed in there for you. All you have to do is type in my inverse operation and solve. I'm going to give you a little hint here. For number 1, I would simplify first. X minus negative 8. A hint, negative. Subtract a negative from a negative. You could change that to X plus 8. Okay? And another hint is I would change number 7. I would change that 7.25 into a fraction to help me out there. Okay? And for number 5, I would use reciprocal. Very, very simple. To the last example that we did, example number 5. Alright. Now, please be careful of your signs. Best of luck. And again, if anything, I am just a click away. Please don't hesitate to contact me. Good luck. Goodbye.